announcement. For the midterm exam, your midterm score is posted on Canvas, so you can check it, but due to the makeup exam, I cannot let you check the midterm exam sheet. So after we finish the makeup exam, I think hopefully Thursday in the classroom, we will check you will be able to check your midterm exam score, exam sheet, okay? So do not miss the class on Thursday. And second thing is also those who need to take the makeup exam, I already informed to those students, please present at on time the place where you take the midterm exam. Okay, and the second thing is your project one. So project one is due on the March 25th, this Friday. I'm going to extend one more week. So due date is April 1st. So I think the April 1st is the Friday, right? It's a Friday. So it will be extended. On Thursday, the GA will, some of the students are confusing how to do the project. So GA will present about the project, how to, those who are struggling to do the project. So we'll give them some ideas how to start and how to successfully complete your project. Okay. The most frequent question was what program language you are using. At this time, you can use any program language. But in this class, the main focus of the project is not the fancy, nice the decoration of your programming. Instead, the most important part is focusing on whether you can implement the algorithm accurately and successfully. That is the main part. So do not spend a lot of time for the very fancy, nice graphical user interface. You can still use the graphical user interface, but at least you should satisfy, your program should satisfy with the requirement on the project description, okay? Which means your output should be displayed as required in the project description, okay? So also if you use any existing idea or any other thing without the proper citation, if we can find the evidence or any copied one, it will be considered as a cheating, automatically 0 marks. So you should be careful, okay? So when you refer any book or article or website or existing code, so that doesn't mean you can, even though you properly cite the reference, but it doesn't mean it will be excused if you just copy and paste, okay? So, but you can get the idea. The due date of the project one is extended to the April 1st. So on Thursday, this Thursday, the GA will brief about your project, okay? And then you will have a chance to check your midterm exam sheet. Okay. Any question regarding to for the midterm? So you will have a chance on Thursday. Any? Okay, so if there's no question about the project, we will continue the lecture. The second part of the semester, first of the half of the semester, we focus on what is the operating system and what is the computer architecture, and we define the objective and the architecture of the operating system. Then mostly we spend the most of time to discuss about the process management. So in your project 0, the 1 minute project, you should be able to create and operate the process using the program language, especially System 4 System Library. In the second part of the semester, so we will discuss about mainly the memory management as well as the I/O management. Regarding to the memory management, so So for your reminder, this one, what is this? This is the computer, the server, or the whatever that we are going to deal with in any subject in computer science system. So we have the main component of the computer as, so this is the two of them. One is CPU, another one is the memory, and also we have a bunch of I/O devices that include, for example, the file system, either hard disk drive or the SSD, or the file system. So then they are connected to the bus. Okay, so this is just very, very high level basic architecture. So let's think about what happens when you execute, when you double click, when you run your programs. The program, what is a program? It's a set of nothing but the instruction. What is the instruction? It's a command. Or command or what? So what is the most important component? If you need to select one of the most important component of the computer, which one? It's definitely CPU, processor. So I still remember when, my daughter, she's right now 16 years old, but when she was even the kindergarten, it's around 5 years old in United States, the education system. So she learned what is a CPU even in her kindergarten classroom. Then her teacher told the CPU is like the brain, the computer. It's like the human being, the brain in the human being. So it can process that command, that instruction. Okay. So in other words, it can process, it can compute. So that how many? It's limited. So depending on the CPU processor, it has some of them has less than 20 the instruction, less than 20 command, and some of them has around 80 or more than 100 the instruction. That depends on you. Probably learn such an instruction, such a code in your microprocessor class or embedded system class, so assembly language. Okay, so your program has such a number of sequence of instruction on your hard disk drive. How do you make this one? You directly code. If you are genius, you can do that, right? So you did. You probably made a simple program, assembly program in the microprocessor class, right? Using for example, very popular instruction move, where what is the next? Register is not the command. We will see the momentary. So what else? Which one is the popular instruction code? The move, subtract, and increment, decrement, and add. Okay. So these are the popular instructions. Can you make? Yes, you can do that. It's very, very hard. So instead, we are using what? High-level program language that you love, right? So Java or .NET and whatever. So such a high-level language is close to the human being. Okay? This is close to what? This one. CPU machine. So this is called machine language or low-level language. This is called high-level language. So using the high-level language, any program language, our goal is to make such a sequence of instruction. Okay? Depending on the programming language, they have the better performance. After we convert this high-level language into the program language. Or sometimes it's very easy, and sometimes very some specific purpose to deal with the operating system part or hardware part. But anyway, any program language will be converted to this one. How? Using compiler. Okay. So because of that, running compiler is one of the most important subject, I believe. So to understand the compiler, you should know this one, you should know this one, even you should know this one. Also operating system. It covers the most of the topic in computer science. Because of that, not many professors try to offer the compiler course. But it's this is one of my favorite subjects.
So when I was a student, we developed a PCAT language, nobody used, but it's educational purpose. So it's a program language, so you can, in one semester, if you successfully implement the compiler, you can understand even programming. Many of the compiler will be coded by C language or C++ language. So you can also, you should be able to understand the program language also. So even though it's not offered a UB, so you can find the online course or the other the research to learn about one of the popular textbook is Ullman, the compiler textbook. Can I remember the Ullman? I believe it's correct. So so we have this one, sequence of instruction. Okay. Then can the CPU execute this one directly? No, definitely not. Why? Because of the speed gap. This is slow. This is so fast. How fast? So for example, when you purchase the CPU processor and what computer, you try to take a look at how fast your CPU is. Then how can it be measured? Using the, for example, 2.6 gigahertz. What does it mean? The 2.6 gigahertz of the CPU. Hertz means how often. Okay, in one cycle, sometimes to process the one instruction, it needs one cycle, or sometimes 2 cycles, it depends. But mostly 1 or 2 cycles are needed. And how many cycles a second? 2.6 gigatimes. Hertz means such a frequency, how often per the given period of time. So that is so fast, but this one, even though we are using the nowadays SSD, so let's say this one, but there's still this kind of media is too slow because we need to find, locate using the address to locate the data and the read and return, so it takes some time. To address that problem, suggest the computer architecture that consists of the CPU and the storage and the media. That is called the memory. So we can use the memory. So instead of directly read the data, data means sometimes data or the instruction code. So directly from the hard disk drive, in other words, program, we will load. We are going to load the set of instruction to the memory, where it's much faster than this one. Then CPU can access this data from the memory. Then what's the problem?
It has a limited space.
Limited space. Which one is bigger? Why don't you take a look at your computer or the laptop? So this one is external storage. It's much bigger than the memory. So memory, mine is 8 gigabyte, 8 gig or the 16 gig, whatever. My storage SSD is 256. Compared to this one, it's much smaller. And another problem is usually expensive. And even though we are we are rich, and so we can afford all the expensive one, so there might be a limitation of the addressing depending on the processing the time. So we cannot keep all the data to the memory. Another problem is a volatile. Okay, so when the power is done, so we will lose the data in the memory. So that is the memory. So in other words, we should be able to manage the memory. Okay, so that is the main objective of the memory management. Okay, then what is the memory? In terms of data structure, what is a memory? So this is not the hardware class, so even I'm not expertise on how to build the kind of the memory. I'm not good at that. But in terms of data structure, computer science point of view, so what is the memory? Anyone?
Heap and it's a combination of heap and stack.
Mm-hmm. It's a combination of the stack and heap. Any other? So raise the heap or the stack? Sometimes. Okay, we can use the memory space as the heap or the stack. Any others? Mostly. This is nothing but what? Array. Array of what? Array of what is the most important part of the memory? Address. Okay, it's actually nothing but if you. I'm not good at the hardware, but if you take a look at, if you zoom in, it's just the kind of grid. Then you can keep the data in the memory. Okay, this data will be represented by nothing but address of the array, sequence of the address. In other words, if we know the address, then we can put the data, save the data. At that time, we can use the heap data structure more. The data structure that we have learned, heap structure or the stack structure, whatever. But it's also basically it's based on the from 000 to the FFF. We have the. Sometimes we can put the you probably learn in your microprocessor class or assembly classes. So it's a binary, right? So binary. So by combining the 4 of them, we can use the hexadecimal. Okay, hexadecimal. And we can put the the most significant bit or the least significant bit. So you probably learn. So it's not an assembly class. So if you want to remind I think the basic stuff of such a memory structure, you can take a look at your microprocessor class or the assembly class, the textbook. Okay, then you can get the idea. So this is nothing but the array of the address, sequence of addresses. So we are going to focus on such address. In other words, one of the problem of this one is from operating system point of view. Anyway, before that, we are going to use the disk space. It's a dry laser. Dry. Looks like the permanent. So this is a memory. So to execute the programs, we need to load this program somewhere in the memory. Okay. Long time ago, how many how many programs can you run on the memory? One. So only one, like the MS-DOS, the DOS program. So they can keep then at the time, you can use only one. So there is not a big issue to use the memory. There is. What kind of the issue? Only one program we can. So nowadays, most of operating system allow multitasking, multi-level program. So we need to share the memory space, but unfortunately, it's limited. We need to manage. So one of the problem of managing the memory space is from the operating system point of view. There's nothing different. Whether this is a process A, process B, as long as you know the address, you can access the data, you can write the data, you can read the data. That means we cannot guarantee the privacy, okay? Privacy of each process. In other words, we need to operating system. The main job of the main memory management is whether we can protect each process. The operating system sometimes is failed to protect each process. Other program, unfortunately, accidentally can access the data. Then operating system cannot handle such a situation that from time to time is popped up or the unexpected or quantum in the C program, like maybe happens. So we are going to deal with discuss how to manage such an issue in the memory management. Okay. So this we already discussed from the program So if we execute the program, it will be loaded into the memory. From the memory, each instruction will be patched by the CPU. That is called. So this is typical the execution cycle when we execute the one instruction. So we are going to fetch the instruction, then decode. What does it mean, decode? Actually, how? For example, what is the most popular instruction? For example, move. So what does it mean? Move BX, CX. What is the BX and CX? This is the register. What is a register? Anyway, we should have the storage to keep the data, even in the CPU, memory. So computer deal with the data, okay, or information in general concept. So where the data is stored in the CPU is a register. Each register has a name. So for example, DX and CX, or in case of the 16-bit EBX, okay, there is the extended, okay. Then always confusing. Which direction? This one? This one? It's this one. CX move to the data, and the CX move to copy to the BX or something like that. Okay, then can the CPU understand this? No, definitely not, because it understands only binary data. Actually, when you compile the this, it's not like the sequence of instruction. It's not like the this. Instead, something binary code. Okay. Then that should be converted to the certain command that is called the decode. For example, I copied one of the popular instructions from the assembly course that I taught before. So this is the move is actually represented by 100011. Depending on your CPU, it has a code. So you can check the reference book of the code of each command. So this is representing the move. Each command has their own code for each CPU. Then I think that this time the BX RM register is the 011 representing the BX, and 001 is the CS. CS is the source and target, something like that. This will be decoded to this one. Then if any operand, in this case this is the data in the BX and CX register, sometimes you need something operand parameter. So if there is a parameter, so you need to fetch such a parameter value, then execute it. So when you fetch the parameter, so at that time sometimes it can have the block it. What does that mean, block it? You don't remember, it's a long time ago. It's not the data in this one. Using the data here is a memory address. Okay, so this memory address will be accessed. So that is called sometimes the fetch operand, or it's usually called the effective address. Okay, you need to find the effective address of the what? It's a memory. So then finally you can execute the instruction. Then any return data, any saved data will be saved in the memory. This is one cycle of the execution. At the time, as you can see, we will use a lot for memory. Okay. So in this class, we will discuss about how to use the memory space. Okay. So this is a basic idea of using the memory. So we have the, from now on, I'm going, if I write the 0 to something number, that means it's the address, low address, starting address to the highest address. Okay, so this, the bar means it's a memory structure. So for example, in this case, we have the operating system. Operating system is also process. It has the sequence of instruction also, as we have learned before, is a kernel, the program. So it will be reside on the mostly beginning of the address. Most of the operating system allow the kernel stay on the beginning of them. Okay. then followed by the other process. If you are using the old operating system like those, so only one processor for the memory space. In this case, we have the multiple processors, so process will be loaded into the memory. When we compile, so this is the address. So for example, each processor has what? Encoded. So let's say there's a move, and move or the increment or decrement, something, the instruction here. At that time, so let's say this process and this process are the exactly same program, but run 2 times. Then this one has something address of the data point to the here. Is this the same address of this process? Definitely not. Depending on where process is located. That is the biggest problem of managing the memory. If we provide during the compilation, if we specify only the disk, for example, integer I is in the 23000000. Okay, if you fix the address, okay, that process must be loaded on this area only. Then even though at that time, even though we do have the free space, we cannot load the process in this area. So we need to address that problem by using the 2 parameters. One is a base and another one is a limit. So base address is the starting of when we execute the program. So where is the starting address of the process? In this case, this process, the base address is the 256000. Okay. So who decides? The operating system. We will see later how to decide. So let's say the operating system decides when this process is executed. Then this process will get the base address as a 256000. Okay. Then the operating system can understand how big the process program is, which means what will be the limit. So limit is the size of the process, how much the memory space are needed for each process. In this case, for example, the 4, 6, this is the size of the process. Then this will be stored and the limit. So there we need 2 values. One is the starting address and another one is the size of the process. When process is started, then the operating system stores such a data where there are 2 registers. Register is in the CPU. Okay, so whenever CPU need to access the data or instruction, anything about this one, first read the data from the base register where is starting. We will see why we need such a base and the limit, especially the base. Okay, then we need to check whether any address is out of this one. Sometimes in this case, the base is the 300040 and limit is this one, which means the highest address is the 420940. That is the plus of this one. Then always check whether address is less than this, bigger than, higher than this. At that time, in case it's less than this and higher than this, it will be error. Okay.
The operating system will not allow actually to access that memory.
Yes, only this one. Why? To protect this process. Okay? And also to protect other address. That's the first thing. Whenever you execute this, okay, for each instruction, follow this one. Before that, check the base and the limit. Then, especially if that is less than base and higher than the limit, you will call the trap signal. Okay? Trap So in the operating system, there's the error, the software error provided by the operating system, the instruction will not be executed. Yes.
How does the limit is decided? How?
Limit is the size of, so you can, the size of the process. Then how
So
many instructions?
The process can dynamically allocate some memory that's not dependent on
Dynamically
the memory.
allocation means, so it's the different. So you have this, for example, state. Okay, you know how big is your program is, but that doesn't mean that you can use only this one. Sometimes you can have shared library, for example, or other Java object that is already in the memory. Okay, then sometimes it can be dynamically linked, or it can be dynamically loaded. So we will see the couple of slides later. But this one is only the static. Okay, the instruction only for this one. This one may use dynamically allocated memory. That doesn't mean, so this is out of scope. Only this instruction will be between the base and the limit. Okay, to protect this, to protect the other process. In case out of scope, you always operating system, the threat or the interrupt signal to then it will be stopped over there. That means for each process, they need to keep base and limit address. Then how can you keep? Using process control block. In the process control block, so you can, one of the data structure of the process control block is copy of all register information. So whenever, even though this is the switch up, after context switch, it's not it's not selected, but next time when this process is selected by the dispatcher or CPU scheduler, then this base and the limit register information will be copied to the CPU. That CPU can continue to access only this area. Okay, this can be usually implemented by the hardware. Okay, software not a problem, but this is happen every time whenever you execute the instruction. So you do better. So CPU, in the CPU design, they have the address protection. Idea is logically it's the same thing that we have discussed. But it's implemented in the part of the CPU. Then they can always check the base and the limit. In case it's less than, it's a base and higher than the base plus limit, it will be the threat. It will be error. Okay, that's the most important part to protect that. Okay, then problem is, as I mentioned here, what if even though we are executing two exactly same process, there, for example, there is in source code we have integer I. Okay, then I is assigned 0. Then that will be converted into the assembly code, right? So assembly code is an instruction. So integer I is somewhere here. Let's say this is a 0 to 100 address. Okay, that 100 is here, but in this case here, the address is different. So there are different ways. So we are going to call to assign the address for the variable is called the binding. Okay, binding. So it's called the binding. So then, however, this binding can be done first during the compiling time. Okay. So how can we do that? We assign that this integer is always 100. 100 is here. Okay. In case of the multi-program or such a operating system, it cannot be used. But the very limitedly, like old version of the operating system, such as the DOS, can use such a binding during the compilation. Okay, it provides the fixed address, static address of the memory. So, however, it's not the flexible. What if we load the process into here or here? So it should be the flexible. So to address that problem, there are two more types of the binding. One is the load time, and another one is the execution time. to understand the loading and to understand the execution, we better take a look at the step of the processing of the user program. I don't know what happened. Hopefully you will see. So we have the source program here. Then after compilation, we have the machine code, or sometimes it's the object module, or it can be DLL or whatever. So anyway, we have the object module. Then what is the load and what is the execution?
The time it takes to put the binary into the main memory is the load time.
If you copy the object module to the memory, that is called loading. Okay. Sometimes we call it as the execution or run. But that doesn't mean your program will be executed by the CPU right away. Okay? It's loaded into the memory, then your program state will be changed into ready. Okay? Ready state. Then your PCB will enter the ready queue. Then, depending on your CPU scheduling algorithm, it will be selected. Okay, then selection is called execution. Okay, so the address is the most important part to manage the memory in terms of program. So that is called the binding. So static binding or the compilation binding is simple. You can decide the fixed address for each process, but it's limited. So there are two types. One is the loading time. Loading time, when you load to the memory, you can decide. Okay? That can be doable most of the time. However, as he mentioned, what if we have the dynamically allocated the memory space, which means I don't need this is my program, but my program in the use something summation function. But this one is implemented by the programmer. That is already loaded into the memory. Okay? I don't have to implement it again. So when you load this program into the memory, you can load it. Okay? That is loading. But that doesn't mean you can execute it right away. So execution means when this instruction is selected by the CPU, okay, this process is selected by the CPU scheduler. Then when you execute the summation, the function, you need to identify, locate this shared library. Sometimes in the Windows program, this is called the DLL. Okay, if you are using the C program, C+ program in Unix or the Windows, it's called the shared library. Okay, so when you compile with the shared library option, does it mean that your library is part of your program?
No.
No. Okay. However, you can do the static library. If you compile with the static library option, then it's copied. It's the part of your program. So when you load, any address binding will be done. Okay. However, the size of the process is much larger. However, if you are using the dynamic linking, okay, using the shared library or DLL, it's not part of your program. It's still small. But you don't know where is it. Okay. Then sometimes that library may be called, okay, maybe not. Okay, not always. In case the routine or library is called, then at the time locate the address. That is. So there are two other types of the binding. One is the loading time, another one is the execution time. So static library or the dynamic library, which one is better?
Depends.
It depends, but hard to say. So mostly the shared library nowadays is performance is not much different than the static library. However, just in case, sometimes, for example, one time, when I manage the database, Oracle database, we migrate the 32-bit system to the 64-bit system. So it was the first time to use the 64-bit, the Unix, the machine. Even it was the first time in my hometown. So worldwide, not many references. It's almost 1998, 7, something like that. It's almost 20 years ago. So we they said it's actually the DEC alpha. DEC alpha is right now is a HP. You cannot see the name of DEC alpha, but DEC alpha is one of the first 64-bit the Unix operating system. So they provide the 64-bit and the C compiler and the library, everything. So they said that you can just recompile every the programming. So we did, but it didn't run. So we tried to solve all the problem, everything, but we cannot. Then finally, one of the engineer from the Oracle, they suggested why don't you compile using the static library. So usually the Oracle, actually when you run the Oracle, any database, they have the Oracle. It's called a kind of a database kernel, but so whenever you connect or execute, and so this one will be the cloned and cloned. So size of this Oracle process is 2 to 3 megabytes usually. But when you when you compile static, the library option, it will be 20 to 30 megabytes, much big. So which means you need more space. But it was solved. So it works. Later we realized that there are dynamic linking to allocate, to find the address. Dynamically, it's a fake. They still use a 32-bit addressing format and some part. Okay? But it was solved by the static because during the load time, all address binding will be done. So if you understand that one, so in case something problem, you can understand. So that is the load time, compiling time. It's not used a lot. It's absolute. It's a static, the fixed address. But there are two other type: load time, execution time. Most of them nowadays use the execution time, the binding. So like the API or library, PLR. Okay. Then, which means we have the different types of address. Okay, so we can understand simply address as we have seen in the high-level program language, like the integer I or the double or float, and the logical address is after we compile, this integer I is from the 100 byte from the beginning. Okay, this is an integer. So this is a relative address. It's called a logical address. Then when we either load, dynamic load or the dynamic link using either the linkage or the loading, so it will be determined. The address will be determined. That address is called the physical address. Okay. I think the logical and versus physical address space, we already discussed about it, so we can. Then the problem is how to, from here, this is a logical address. We have the 100, so from the beginning. But we don't know where it will be located, where this process will be located. We need to always use base and limit to locate the exact location of the variable. So we need to every time add check this how many times, like the 2 gigahertz, almost 2 giga times. You need to check that this one. It's overhead. Anyway, even though you are using the hardware, the implementation of this such addressing, you need to anyway run 2 giga times of this such add and compare. So less than, higher than, which means it's 2 giga times 2, 4 giga times. So a lot. Okay, it's still overhead. To reduce the overhead, we can manage something mapping table, lookup table. That is called the memory management unit. So memory management unit provides such a mapping table between logical address and physical address. Instead of calculating add-on, it looks like the simple. So any problem? It's not a problem. Just calculate the 1 time or 2 times. What if within a second 4 giga times calculation is a huge overhead. So instead, calculation. So because once this process is loaded, we need to swap out, roll out, and swap in, swap out, swap in. No, we don't have to. So until the process is terminated, it will reside on the same space of the memory. Okay? So which means the address of I will not be changed until it is terminated. So that means, why don't we manage? Integer I is the logical address is 100. This is a 500. So if we have such a mapping table without calculation, we can find location of the data. That is called the memory management unit. Okay? It's nothing but such a mapping table between logical address, physical address. So when you find the location of the disk, the logical address 500, it will be 2000. So you can go to the 2000 like that. Problem? Accessing the memory management unit, it still takes a time. So where we can put the MMU? It's also
In memory.
memory. Okay. Then, which means the CPU should have the address, the register to point out this one. This mechanism will be used a lot. We will see. Practically, this one is not used. The movies, but idea is the same thing. So this is called the MMU, address mapping table. Okay. So then using such a thing, so we can relocate, dynamically relocate using the relocation, the register. Idea is the same. Still, idea is the same. The most basic approach is the base and limit the register. At this time, we can use the relocation register. Relocation register is just the logical address we can add in the memory using the memory management unit. Then we can find the physical address of the memory. So then finally we can implement the dynamic. We already discussed about what is the dynamic loading. Okay. What is the idea of the dynamic loading? Okay. Comparing to the static loading. Even though we implement very fancy, nice programming, so think about the Microsoft Word. Are you using all the functionality of the Microsoft Word? Probably less than 10%. Even I still struggling to find each. So every time I need to do Googling. So how to do this one, how to do this one. Not all the functionality will be used. It's the same idea. If the certain routine, we are going to call that part as a routine, is not used, not load into the memory. In case that is called, but that routine is used, then load into the memory. One is nothing but the maximize the memory utilization. So that is called the dynamic loading. Okay. And linking. What is the difference? The loading and linking. Loading is when you execute the program, load copy into the memory. That is the loading. Okay. So whenever the routine is called, you can load into the memory again. That is called dynamic loading. Okay. Dynamic linking is already in the memory as a form of the shared library or DLL or the API library is already. When the specific instruction is executed, during the execution, that will be linked. Okay, so that is called the dynamic linking. That the small piece of the code is called stop. Okay, then it will be used in memory. Most popular dynamic linking is the shared library that have you been used in your C program. Okay, LIB. You can use many shared library, the dot something, dot
Not SO.
S or SO. SO is the shared library. Okay. In your so right now in 500 is the object-oriented programming. What is the program language required in our course, our program?
C++.
C++. Do you learn the C++ in the object-oriented programming? So what about the Java? You do not learn the Java?
It's an optional course for graduate students.
So right now, 500?
501.
501. 501, you learn the C++. Okay. What is a compiler?
Compiler?
Yes. So are you using the .NET, the environment, or the Unix?
Is there any course on compiler?
Visual Studio. You are using the Visual Studio and the C++ compiler in the Visual Studio. Okay. Still, C language is the most popular, okay, in the IT industry. So do not lose, okay, do not ignore the importance of the C or C++. So still it's a controversial whether we need to change the program language into the, right now some of the university already changed their program language into the shell script languages such as Python or the Perl. Okay, so they offer the data structure class or the object-oriented programming class with such the script language. But I still believe the C and the C++ is the most fundamental and the basic, the programming language. Okay, then so main part of the addressing is we already discussed about addressing using the base and the limit, and also using the MMU, the memory management unit, so we can the mapping between the logical address and the physical address, and also we can implement the relocation register with the MMU. Then finally we can decide the physical address. Then the next operator management issue in the memory is, as we have discussed before, the memory, main problem of the memory is not big enough. Okay, it's not unlimited. It's a limited, very, very limited. So all the operating system use the only one process in the memory. But nowadays we can use the many processes, but still we need to use something dynamic linking. What is the main purpose of the dynamic linking? Maximize the utilization, because we have the limited resources. So what if it's run out of memory space? We need to take out the unused processes in the memory. That's the only way. Okay? So we need to, so all the operating system use, take out from the non-operating system, we cannot take out the operating system, and certain of the process into the hard disk drive. Then bring the new process into the memory. That is called swapping. Okay? Have you ever heard about the swapping?
Yes.
In your operating system? Yes. So we still use the swapping in our operating system? Yes, one.
Yes.
Yes?
Yes, we do, but very limitedly because we have too much memory.
So, because the swapping, as you can expect, what's the main problem of the swapping? It takes a time, right? So, idea is simple. Why don't you roll out, which means you need transfer, okay? Transfer time, okay? So you do the first, write the data into hard disk drive, then also read the data and copy it to the memory. It takes some time. So it's not the current operating system actually not use the swapping as it is. Instead, name of swap is used, but it's a slightly changed concept. For example, in Linux, when I insert the Linux operating system first time, it was very, very painful. It's not like the Ubuntu, the current Ubuntu or the CentOS, it's not like that. I need to specify all the device and the space. One of them is a swap space.
Yeah. You
Okay.
still have it.
So, however, that doesn't mean that area is used for that swap. Instead, it will be used for nowadays virtual memory. So we are going to see what is the virtual memory later. The name is still used. It's very popular, but it's not used as it is. It's a different the way. Also, very limitedly, the swap can be used for the certain embedded operating system. Okay. What about the mobile device operating system, Android or iOS? Do they use the swap? Probably not, because it takes a long time. So they do not use the swap concept. Okay, so that is temporary. They can back up the current process and bring the process. Problem, which one will be selected? We can use the lower priority, but we are not going to take a look at the details because we are not using a lot the swapping as it is. Okay, but you can understand what is a swapping. So idea is a swap out, swap in, or roll out, the roll in between memory and this is the storage. Okay. So you can actually calculate the context switch time during the swapping. So it's nothing but the calculation of the for the speed and the size. Then you can calculate the time. It takes time. Okay. So I'm going to skip this part. It's just a simple math. Okay, you can calculate how long it takes. Okay. What about the swapping in the mobile device? Actually, what is the main difference between the general, the operating system, and mobile device operating system? Actually, it's the same operating system. So actually, the mobile device, the operating iOS and the Android, they borrow the most of the idea from the, or even existing code from the general operating system. Then they customize to fit what? The mobile device. What is the main characteristic of the mobile device hardware? Power. Okay. So most important part is how to save the power. So first, they do not use the swapping because it needs a lot of I/O. So instead they support the pacing. Okay, that we are going to discuss later. Okay, before we start the pacing, so even though the current most of the operating system do not use this one, we will quickly take a look at how to use the memory space. So we have discussed about the addressing, which is the most dominant characteristic of the memory, and how to protect the memory using the base and limit or the MMU and so on. And also there is the swap operation, the bring in and out. Then where we can bring in and out. In other words, how to allocate. We actually skipped just before. So how to allocate the memory space for the this one. The first approach is the contiguous allocation. Contiguous, as you can imagine, entire the program and will be loaded into the free chunk of the memory. That is called the contiguous allocation. To do that, we need the free enough size of the free space. Okay, contiguous free space. That's called sometimes the partition or the chunk. It's not important. So, how can we allocate? There are different ways. So, for that, let's say that this is for example the memory. So, beginning part is operating system. Currently, process 5, 8, 2 are in the memory. Then there's no space for the process 9 and 10, so we decide the process 8, swap out. Okay, then we have the free space. This is called the free chunk or port. So this port, this hole can be used for another process. What if we have a different number of holes or free chunk? At that time, we can think about the several different algorithms. The first one is the first fit, best fit, worst fit. First fit means first free chunk will be allocated. That should be bigger than the process size. Okay? If less than process size, the next one. That is the first fit. Best fit is most close size, which means leftover will be minimized. So for example, I don't know what happened. This is OS 1000. So this is a 1, this is a 2000, this is a 4000, this is a 4500. So let's say there are 3 holes, 3 chunks. This is the separated. Okay, so our program size is 400 bytes. So any of them are available. For the first fit, we can allocate the first hole. Okay, H1, because it's the first available chunk. Using the best fit means the after allocation, for example, 400, if you allocate the 400, you have the 600, the leftover. This is also chunk, free chunk, it's a hole. And if you allocate it here, it will return 1600, the available space. This one is the 100. So best fit is, which one is the best one? In other words, which one make the smallest available chunk left over. That is the best fit. Worst fit is the opposite of the best fit, the biggest one. We cannot say this one is the best one, because best fit, you can have the biggest chunk. Okay, this is a maybe use the small program, but may not be used if most of the process is bigger than 100 bytes. So not always best fit is the best. Okay, so it depends. So this is the contiguous allocation used in the old operating system. This is just an example. So, for example, let's say the H is the hole, is a free chunk, and free chunk. The P3, P4 is a process, the ID, process number. So, for example, the H1 is a 600. This is a 600. This is the also 600, and this is the 400. So, using the first fit, the P1 will be allocated here, like this one. And for the best fit, H3, right? So H3, because the leftover will be, so in this case, 100. And the worst fit, so this one is a 600. This is also 600. Okay? Then why? At the time, you can use any typewriter. Okay? It can be either H1 or H2. Okay. Problem? For example, in this case, we have the 700 byte size of the process. Even though we have enough space, it cannot be allocated because this is a continuous allocation. Okay, so this is called the fragmentation. There are 2 types of the fragmentation we will see. You have seen a lot of such a fragmentation situation in your experience. Where?
File system.
File system. Do you remember the old version of the Windows?
Yes.
So Windows 95.
98.
So from time to time you did defragmentation. That's the the sample of the fragmentation. But in fragmentation means it's a small piece. So even though you have the enough total space, you cannot use them. That is called the fragmentation. Fragmentation is not only the issue of the utilization, but also problem of performance. Fragment, if the system is not only for the file system, it can be memory, any storage. If fragmented, that means it's overhead to manage. And also takes a long time to access the data. You need to visit more. Okay? So there are two types of fragmentation. One is external fragmentation, like the file system fragmentation. So externally you have the chunk, but you cannot use it. That is the external fragmentation. There is another one, internal fragmentation. What is the internal fragmentation?
Memory. Fragmentation in the memory.
Fragmentation in the memory. When you have the certain data structure, okay, like the operating system block, okay. So you have the most of the internal fragmentation is a fixed size of data structure. So you are using, for example, what is the typical size of the operating system block size? I think that we didn't discuss yet. So we will discuss. It's a 512 byte. It's the most popular one. Okay. So what this block will be used for later? We will discuss I/O unit. It's a basic I/O unit, which means when you read the data, it's even though I need only 1 byte of data, but entire block will be written. That is the I/O unit. So that is the reason it's the OS block size is very important. That affect the mode of application of your operating system. In this case, so I use a 500 byte. The remainder is a 12 byte. But you cannot use 12 byte because it's inside of the data structure. So there are two types of the fragmentation. It's the same problem in the memory also. So here there is no problem of the internal fragmentation, okay, but it causes the external fragmentation. So how can we address problem of the fragmentation here? We are going to use continuous, right? You don't have to use. Are you going to use? So this one, because we are using continuous, okay, contiguous, the chunk of the free space that causes the fragmentation issue. Then why not use the continuous, non-continuous approach? So how? I already gave the hint of this one. Instead, why don't we use fixed size of the memory unit, like the OS block? So when we have the memory, we divide. Small fixed size of the area, like this is a 512 byte. And so 1, 0, 1, 2, 3, 4, 5, 6, something like the structure. Okay? So this is called page. Have you ever heard about the paging?
Yes.
Or not? Okay? Especially for the memory. I will show you later. So why the paging is important. So instead of such a chunk continuous data, first divide your memory. This is called the page frame. Okay? So instead of the big chunk of the process to load the memory, we are going to divide same size of the
Page.
data structure. It's called also page. Okay? For the program. Then load page by page. So let's say we have 0, 1, 2, 3, 4 pages. 0 can be, this is a page frame number. This is 0 can be here. 0, 1, 2, 3. Like that. Okay? This is called the page approach. Contiguous is easy. So we can find, as long as we can find enough space, you can allocate and load into the memory. But it may cause fragmentation. Is how to address? why don't we use the small fixed size of the unit that is called the page? This is a memory, your memory. So this is called the page frame. So you have a number of page frame. Then we are going to divide the program by the same size. This is called the page, logical page. Okay, logical program. So that's a physical, this is a logical. Then we can, instead of the entire program, we can load page by page to the memory. This is a page approach. Then, one of the benefits of using such a page is you can remove
Any page.
a lot of the fragmentation. Okay? As long as you can find the free frame, so you can load into the memory. So you can avoid a lot of external fragmentation. However, it still has the small internal fragmentation. For example, the last one has only 1 byte, but entire page should be allocated. Still has the small, almost ignorable, but anyway, it still has the internal fragmentation. Another benefit of using the page is it's not program by or the chunk by chunk. It's a page by page. It's a fixed size. If we can count the number of pages moving to here or the page out, page in, page out, we can count it. Then that number will be indicator of what? Performance. So that's the reason when you monitor your operating system, first, CPU. You can monitor CPU. The user, what is the user time? What is the sys time? What is the average load time? What is the average, the active program? That is the CPU monitoring. Another one is file system monitoring. How many input? How many write? How many read? How many cache read? So that is the another factor. For the memory, you can check how many page in, how many page out. Okay? Then you can judge whether your system is good or not. Okay? So we will see details about such a thing. Another important thing is the page fault. Okay? So we will see what is a page fault, what is a page in, what is a page out, then why the page fault are important when you judge your system in the next class. Okay? So any question? The next class, we will continue the memory management, and also you will have a time to check the midterm exam sheet, and also what else? The project description. So our project is extended to the April 1st, 1 week extension. So the Thursday, the GA will brief about the instruction of your project 1. Okay, thank you, and see you.